In this video, we're going to be finding some absolute extrema for a function with fractional exponents. So my example here is going to say find the absolute extrema of the function 4x raised to the 5/4 minus 8x to the 1/4 on the closed interval from 0 to 4. Okay, so this is pretty standard extreme value theorem problem. The only thing is you've got those fractional exponents that you have to deal with, which makes it a little more tricky. Okay, but because I am looking for absolute extrema and I am on a closed interval, then we can use the extreme value theorem. Okay, so that's one that we are going to apply. Extreme value theorem says that we can test our test our critical numbers and endpoints in order to find that absolute extrema. Okay, so we're going to test our endpoints and our critical numbers, and we will then be able to find our absolute extrema. So first off, we need to take that original function and find the derivative. So let's rewrite the original function here. F of x equals 4x to the 5/4 minus an 8x to the 1/4. Alright, if I go to find the derivative here, I'm going to take 4 times 5/4, which is going to leave me with a 5x. Subtracting 1 here will give me a 1/4. 5/4 minus 4/4. Taking the derivative here, 8 times 1/4 is going to give me 2, and then x raised to the, if I subtract 4/4, that'll give me a negative 3/4. Alright, now, to find critical numbers, I need to take that derivative and set it equal to 0. But with those negative exponent or negative exponent that's a fraction and this fraction here, it's going to be easier if we factor it, set it equal to 0, and try to eliminate as many of these fractional exponents as we can. Alright, now if you can factor out a greatest common factor, you're going to do that the same way that you always do. You're going to look at those variables and you're going to factor out the smallest exponent. I have a 1/4 here, I have a negative 3/4 here. So my greatest common factor is going to be an x raised to the negative 3/4. And that's what I'm going to be taking out. Alright, so 5x to the 1/4, factor out an x to the negative 3/4, well I know I have my 5 left over. And I'm going to have x raised to some power. Now you just got to think this through, okay? When multiplying like bases, we add those exponents to get to 1/4. So negative 3/4 plus what will give me a 1/4? Well, it's going to be 1, or 4/4. So it's just a 5x. Okay, this term, factor out the x to the negative 3/4, it's going to leave me with the 2, and then the x to the negative 3/4 got factored out. Okay, now at this point, I would probably attempt to get rid of that negative exponent there. We can move that to the bottom and make it a positive exponent. So I would write this derivative as a 5x minus 2 all over an x raised to the 3/4. Alright, now at this point you're going to need to find your critical numbers. So let's do that right about here. So critical numbers. I'm going to take this derivative that I found and I'm going to set both the numerator and the denominator equal to 0. So I'm going to do a 5x minus 2 equals 0. That's going to give me, by adding 2 and then dividing by 5, that's going to give me an x equals 2/5 as a critical number. And then taking that denominator, x raised to the 3/4 equals 0, setting that to 0, and then multiplying both sides, raising it to the 4/3 power, raising it to the 4/3 power there will give me an x equals 0. Okay, so those are my critical numbers. Taking a look at 0 here, my first derivative at 0 is undefined. However, 0 is in the domain of that original function, so then both 2/5 and 0 are critical numbers. Okay, so now that I've found my critical numbers, I can take the two critical numbers and both of the endpoints because of the extreme value theorem and test them. Alright, and I generally just test them in an XY table. So let's create an XY table here. Alright, I'm going to put my endpoints in first. So I'm going to put 0 in and I'm going to put 4 in as endpoints. Alright, critical numbers, 0 is an endpoint as well, so I only need to put it in my chart once, and then I'll put the 2/5 in. Okay, so we're going to make a note here that these are our endpoints, and this is critical numbers. Okay, because for extreme value theorem, those are the two things we're going to test. All right, now at this point, with that original function there being with those fractional exponents, I would definitely use a calculator to calculate this, as long as you were allowed to do that. I would not do that by hand. So if you want to pause the video and try that with your calculator, you can. I'm just going to give you the answers here. Plugging 0 in there, that's pretty easy. I'm going to get 0. Plugging 4 into both of those places, I get about an 11.3137, and plugging in the 2/5, I get about a negative 5.0897. Okay, but definitely, pause the video, make sure that you can put that original function in your calculator and get these values in your table. Now, looking at this XY table, now I can find my absolute extrema. So obviously 11.3 is my biggest y value, and the negative 5.0 is my lowest value. So my max is going to occur at x equals 4. My min is going to occur at x equals 2/5. And generally I write them as ordered pairs. So let's here write max at the ordered pair 4, and then 11.314 will go out 3 places because the AP test does that. And we have a min then at 2/5 and negative 5.090, rounding out 3 places there. Okay, so main purpose of this video is refreshing you with the extreme value theorem, but just dealing with those fractional exponents and showing how you can factor out a greatest common factor and then manipulate that derivative so it makes it a little bit easier to deal with and work with, so that you can easily find those critical numbers. Definitely thanks for watching, and don't forget to subscribe to the channel. Thanks.